So today I just want to run you through my boring head ball turning attachment. Now a while ago I built a rotating ball turning attachment to fit onto my top slide, and while it was reasonably successful, you know, it was good for sort of putting radiuses on end of bars and you know, basic ball turning. I found it difficult to set up with the way I built it, and that it wasn't the best. It wasn't the best design in the world. So it sort of it got shelved, and I didn't really do a lot with it for a while. And then a few weeks ago, a friend of mine who does wood turning, he wanted some little knobs making up. So some little brass knobs, things like that. Basically to go on the lids of his pots. So, you know, a nice little turned brass ball on the top as a little knob. So it got me back into thinking, you know, if I want to make some of these regular for him, I could do with a better system. So I was on YouTube, as you do, and of course I spotted a couple of guys, 2 or 3 guys on YouTube who were using one of these, which is a boring head, and they'd basically modified it to go into the lathe, top sliding where the tool holding is, and using it very successfully to do ball turning. And of course it's fully adjustable, so a lot more easier to set up than my original ball turning tool there. So I needed to sort of modify this so I could actually set it up you know, in a quick change tool post. So, you know, one of these quick change tool posts, so that needed to sort of somehow hold this so it'll drop into the lathe, and then obviously you can rotate it round to do the ball cutting. So the first problem, obviously, it comes with a MT2 tapered sleeve, and you know, that's used to obviously fitting into my milling machine, etc. So I need to make myself a new arbor with a straight shank. Now the thread on this is 1.5 inch sort of major diameter there, and I worked it out, it was 18 teeth per inch thread on there. So I set about making from I used some cold rolled steel, which was blooming hard going actually, but I turned it down to 1.5 inch major diameter to put the thread on, and then I turned the rest of the spindle down to 3/4 inch, and then I tapped a M8 hole at the back there, threaded M8, and that's to accept the locking screw at the end. And it doesn't have a shoulder as this one does, because I was simply going to actually use this surface here on the back of the head as the sort of bearing surface, rather than well, I didn't have any stock wide enough to put a shoulder on it anyway. So the next thing I did, I got some 2 inch aluminium round bar, and I bought it's how long is that? That's 2 3/4 inches long by 2 inch diameter, or it might be 50 mil, and I bored a nice hole in there so that would be a good sort of suction fit on there, a bit like a piston. It doesn't do it, I've got the holes in there, but basically that needs to be a nice sort of a nice good you know, a good running fit in there, because obviously that needs to rotate, but without any sort of perceivable sort of wobble in there. And I milled a 1/4 inch deep by 3/8 groove in there, and that simply will be for the metal bar which will go in, which will become the part which attaches to the quick change tool holder there. Now, because when all this is assembled, it's quite far forward. You know, if you can imagine, that's on there, and then you've got a cutter out the front. So, you know, you need to move the whole of the cross slide back quite a long way. So I decided to just extend the holder slightly and put a notch in there, so that won't sort of interfere with the boring head when it's attached to the bushing here. So that was drilled and counterbored to accept 2 sort of 4mm M4 bolts. So that just drops in there, just drop the screws in. Anyway, there you go. So that's, like I say, that's screwed into that that little groove that I cut out there, and then it's been milled off at the front there, just to allow some clearance for the actual for the boring head. Now, like I say, I made this straight shanked mandrel, so that simply screws on there as well, in replacement of the Morse taper mandrel. And what I did, I was a little bit concerned that when it was in use, being turned, it might unscrew itself, so I simply drilled through the boring head and then tapped it to 4mm, so I can now just run that 4mm grub screw down in there, and now of course there's no chance that, you know, that's going to come off. And simply it slots in there. What I'd normally put a drop of oil on there, and like I said earlier, those two surfaces there just sort of come against each other, and that becomes, because that's just slightly turned slightly lower than the surface of that perimeter edge there, so the bearing surface is that against the aluminium face there. Okay, now obviously excuse me, I need to be able to somehow hold that so I can turn it. So the back piece is again just another piece turned from the same aluminium bar, and it's just got an 8mm shaft there, which is obviously I've drilled out and threaded it at a sort of a 45-degree angle. And the first one I did was a little bit long, and it kept catching with the cross slide handle, so I shortened that a bit, but it probably could do with being a little bit shorter still. And then I turned the little spigot there, so it actually comes in and it mates up with the end of the bar, on the end of the arbor. And this diameter between there and there is about 1 thou longer than the actual length of this tube. So when it gets put together, that drops in there, and then I simply use a 8mm cap screw. That drops in there. And then I can tighten that up. I just want to set that so it's, I don't want to set it. That's it. So the cutting tool will be in the sort of edge hole, and obviously I want to be able to rotate that round, so round to the, you know, to the back of the piece that I'm cutting, and then back to the front. So I want that handle sort of roughly in that sort of position about there. So I simply, well, I tighten that up. I'll pop that, actually I'll just drop that in the vise, just clamp it in the vise just there, and I'll really lamp that up so that, oh, you can't see that, can you? So I'll just drop that in, hold that in the vise there, and then I'll tighten that screw up, because obviously that's another candidate for becoming undone as I'm using it. So I'll just do that now over on the vise. Okay, so that's now all nice and tight, and I presume you can start to see how this is going to work. Basically I put a cutting tool in the front there, and then I can set this at centre height, and then I can use that to turn a ball or a knob or something like that, such as this here that I did on it earlier. So the next thing of course you need is, well, I need to clamp on my quick change tool post there. So where's my, lost my, oh there it is. So I'll just tighten that up. And like I say, it sits just slightly forward, just so that I can sit it as far back on the tool post as possible. A bit of swarf on there. And the other thing I did, as you can see that flat there, the flat that's been milled on the surface, that's simply that when I do mount this in the tool post, I can use something against the chuck, etc., and I've got a sort of reference surface, so I know that that is you know, that it's going to be set up you know, at 90 degrees to the workpiece, so it is nice and square. Just tighten these up, take a while, bit of a slow process. Okay, now the cutting tool, originally I built one of these, which is basically, it's 12mm silver steel, and it's just been drilled at sort of a slight angle, so it gives a little bit of clearance on there, so that's not going to sort of come into contact with the work. And then that's just a bit of 6mm high-speed steel. It was actually a, you know, a broken centre drill, so I tend to break quite a few of these. So basically that was just well, ground off to so you end up with a flat, and then there's just a tiny little bit of a sort of bit of backing off there. So there's it's just backed off very slightly, so there's a slight relief angle on there, and that will sit into the like that. And I've also put a flat on there so that you know, it sort of sets it at the right angle. But also what I've built, and this is what I'm going to try out today. Although this cut quite well on brass, etc., it did tend to pick up a little bit on aluminium. I perhaps should have used a little bit more lubricant or something, but I wasn't entirely happy with that. And also, obviously, as it comes sort of round the side of the ball, as that sort of comes round here, it's sort of oops, can you see that? So you know, you start over the top and you cut like that. But as it comes around here, of course, you know, you've got this the angle, the relief angle isn't correct anymore. It's sort of, you know, it's the wrong way basically. So what I thought I'd build is the same sort of thing. So it's another piece of 12mm steel, again with the slot out, and I've just turned that down to the sort of small diameter of it's a little carbide, is it CMT 06 or something like that. Basically it's a 6mm by 2mm carbide you know, form tool, round form tool, and that's fixed to that shaft via its little miniature torque screw, which I did have to actually buy a set of taps for them, or not a set of taps, but it's weird that it's actually it's M2.5. Is that in focus? It's M2.5 by 0.45 for the actual thread diameter. So I did have to buy that just simply for a one-off job, mounting that in there. But you know, who knows? I might make some other lathe tools in the future that require a carbide insert. Anyway, that's sorted. But obviously that now has got its the relief angle on the carbide is obviously built into the carbide. So as that turns, as that goes around the ball, it should remain you know, in a sort of the correct cutting angle as it goes around, all the way around. Okay, so I'm going to try that one out tonight. One other thing, let me just drop that in there, tighten that up. Okay, so that just tightens up onto that flat, just stops that moving. And what I was finding when it was in use, obviously it's mounted in the lathe like that. Now the adjustment is usually do the adjustment when it's on the top, because the top piece is always kind of the last piece to be cut, and unfortunately the adjustment on the boring head is on the opposite side to the placement of this. I mean, if it had a hole there it'd be absolutely perfect, but it doesn't. So I did see a guy who built one of these on one of the engineering Facebook groups, and he'd got around the problem by simply drilling out and putting a grub screw in there. So that is also what I've done. I took the shaft out, unscrewed the shaft, mounted it up on the lathe, drilled you know, a 5mm 4.8mm hole, tapped that out to M6, and then I've just put a grub screw in there which bottoms out on the hole. I had to use a plug tab to be able to, get to the bottom of the hole, but that just bottoms out nicely, so it's nice and tight. And then obviously I also ran a little bit of Loctite in there, some red Loctite, so that hopefully shouldn't come loose. And then of course I can simply do the adjustment of the boring head cutting dimension by using that at the top. Oops, thought it'd come loose then. It wouldn't have been very good. But as you can see now, that can be adjusted from the top as well as from the bottom. A little bit of backlash in there. So I'll get this all, I'll just tighten it all up, make sure it's all good, and then I'll get it mounted up on the lathe, get it all centered up, and then I'll do a little bit of ball turning to demonstrate how it works. So just for a demonstration, I'm going to turn something like, it's basically a little brass knob from some 20mm round stock. So I've mounted that in there, and then first of all there's a little bit of preparatory turning that you need to do. So I just need to face off the front of that bar, which I'll just do quickly. Okay, so I'll just face that off. So this stock is 18mm, okay, so you just take a reference from that, and then I'm just going to score 18mm in using the vernier. Okay, so that gives me a line there, and then I'm going to go 6mm, so I'm going to 18, so 24, somewhere close, and just do another score line there, as you can see. And so the preparatory turning is, I just want to reduce that in there. So if I just swap my tool out, and I'm actually going to use this, it's actually a 6mm, the same tip that is in the ball turner. And I'm just going to reduce that shank down, and there's no dimensions in this at the minute because I'm just sort of just roughing out, so I sort of just plunge cut into there. Okay, so I've just done a plunge cut into there just to create the recess required for when the ball turner comes round. And so now I want to set the ball turner up, so I'll just zoom out. Okay, so what I want to do, drop the ball turner into the quick change tool post, and just to check that it's nice and square, like I talked earlier about this reference face here. Remember I referenced this this flat surface that I've got here, and what I can do is I can use the surface of my I won't use that bit. I can use the flat surface of the chuck there with this square that I've got, cylinder square, and I can just I can hold that flush up against there, and then just pull in my tool so it's flat against that edge there, and then of course I can lock that up. Okay, now because there's because the forces on this are all directly back as it's cutting, and if you imagine a normal cutting tool, that's sat there and the forces are all pushing downwards on the cutting tool. I'm essentially using the cutting tool in this direction and rotating it around to put the same cut on, but rather than the forces now all being down, the forces are all back this way. So you need to make sure that this the setup here is as rigid as possible. So you know, certainly on the top slide the bolts need to be nice and tight, but also this this clamp here for the tool post needs to be nice and tight. Okay, because you don't want anything suddenly moving while you're cutting. I've already preset the height of the cutting tool, so that is on centre. So now to align up ready for cutting, it's simply a case of bring the cutting tool in so it's more or less sort of central. If you can kind of just gauge that by looking at the where the centre line is from when you're digifacing off, and then you can bring that in over the top. So you can use just a scrap of paper, and you now want to set your centre height. So I'll wind that down just until it sort of traps the paper. So I know now I'm about the thickness of the piece of paper away from being on centre. So then if you move that out and then bring that round to horizontal rather, and then bring that in just to touch that face there. Okay, you know now that you're going to be more or less sort of centered, so you can lock that off, lock off on the saddle lock there, and then it's a case of where's it gone? There it is. So I'm just going to crank that back a few moves. It'll be easier once it starts getting up there. That's it. Okay, and I want to bring that back until it just clears the corners. Okay, so now that's cleared. So basically I'm just going to well, I'll go back a little bit more, and then I'm just going to take out the backlash there. Yeah, you got that? So it's just catching that top corner there. Okay, so now I know I'm centrally that way because I lined up on the face of that. And so basically I'm centered all around, so I can then start the cutting. So just check everything clears, start the lathe up, and then as you can see, just skims the front and back. And then all you simply do, you can get to the top, and then you can add some cut. So I'm just going to rotate that round, so that'll give me 0.5 millimetre of cut. Same, another rotation, and then basically you just want to work it down towards the centre of the job each time, a little bit at a time, and just nice and gentle on the handle, just till you come into there, and then over to the other side. Bit more, and you can always see how much further you've got to go. I've got about 2 mil to go there from the front reference face, because obviously when you've done your final cut, that the tip of the cutter will be actually just touching that front face, or will probably be just in a fraction actually. So I'll just zoom in on that, and then I'll complete with the cuts. So again, I'll just add a bit of a cut. And I just take it down there until it just touches the bottom of the recess that I cut earlier. Again, just add a little bit more cut. bit more. You start to see it forming now. I'm just going to take a bit more off there. Okay, that's looking better. Nice brush shower. Still a bit more to go. And obviously these are just roughing cuts. It's just starting to touch now, look, so you can hear it when it gets to the point where it's more or less on the top. And also, this is where you get your reference for your centre point, whether you're actually on centre. Just turn that in a bit. As you can see there, I don't know whether you can you see that? There's a tiny little nipple on there, so I'm not actually fully on centre in that direction. So I can now just increase that a fraction, go in a couple of thou, and it's nearly there now. So we'll just take it back to the top, and I don't want to go all the way in because I want to leave that for the actual final cut. If I just go in another fraction, still just skip it over the top. Still not quite round there. And you can see it's sort of starting to get there. And then the final cuts I've put on while I'm moving it. So you're not kind of digging in. Still a bit loose on the top, still needs a fraction more. So again, while I'm sort of moving it, I just add a bit of cut. Add a little bit more. Okay. Bring that round. There's still a tiny little nipple on there. That's good because that's what I want. Because for the final cut I basically just advance via the cross slide, so I'll just bring it in a little bit at a time until that nipple disappears. And it's nearly gone now. Another couple of thou in, and there it is, it's gone. So that is basically the final size. So now I do a nice slow rotation. All the way around. It's actually not quite there, it's still a bit loose at the top, I can feel that. So I'm just going to add a tiny bit more. Do one more final cut. I'm quite happy with that. I'm just going to reduce that a fraction, and now I'm going to wind that off. And as you can see there, just move that out of the way. I've turned myself a nice a nice brass ball there. So just to finish off, I'd then probably go in, take the ball cutter out, and then probably go back in with my round radius tool, just clean up those edges there. Obviously, if you wanted to make a complete round ball handle, you'd probably turn a piece of brass to the right diameter, drill and tap it, and then make yourself a little sort of stub mandrel with a thread on it, so you can screw that piece onto the stub sort of mandrel, and then you can turn it right down until it sort of basically until it starts to touch the thread, and then you've got a fully circular sort of ball with the thread inside. But for this instance, I'll just go in and I'll just clean that up. I'll bring that into the ball that I've cut. Then I'm just going to feather that out actually. Put a little bit of a radius on there. Just clean that up. Just put a little bit more radius on. I'm doing that by basically moving the cross slide and the carriage at the same time, just to to give you that little radius there. And then of course I can just part that off. So I'll just use my rear tool post parting tool. Bring that into where I want to be. Down there somewhere. It's not critical, this is just a demonstration part. I'll just slightly part that off, part that off, if there's a word for that. Just put a little radius in using my a chamfer, using my chamfer tool. Parting tool back in, try and realign it where it was, just come in and touch the far side, come back, touch it again, come in until it's just rubbing there. You can just hear it, lock it off, and then I can part that off. There you go. So there you go, a nice little knob. I mean, I could just, obviously this is just a demonstration, but you could drill and tap the back of that, or you could even turn it. When you turn your recess in there, you could have a bit of a stem, which will allow you to tap. But yeah, nice simple little device made from the boring head. Really quite easy to knock up. You don't really need any bearings or anything, because simply it's only moving sort of 180 degrees maximum. So yeah, I mean, have a go at building one yourself. Really simple. I'm really quite pleased actually with the carbide. Oops, that's a bit shiny. I'm really quite pleased with the carbide cutter. That seemed to have worked much better than just using the piece of high-speed steel, because obviously it's got the radius which is correct on all angles, so you can't really go wrong with it. So yeah, there you go. So as you can see, it's quite a capable little ball turner really. Nice little knobs, balls, etc, etc. Oops, made that one out of aluminium. Little brass knobs. All's good. Thanks for watching.